Hello everyone, we should be live already. So it's great to have you all here. Just gonna wait for a second to everyone to give the opportunity to everyone to join the webinar. We hope you're gonna enjoy it. It's a very exciting topic we will discuss today, and we're really looking forward for you to attend this and hear your feedback on that. In the meantime, I have the feedback on the video and audio. I'm gonna present myself. I'm Elena Manole. I'm working with Kebula, and I'm doing business and business, a bit of educational side, a bit of marketing, a bit of everything that helps the company to educate as many people out there as possible on the topics that are involving our customers. Let me double check just a second if the audio is on, and then we can go live. So in the meantime, Adam, if you want to present yourself as well.
Yeah, no worries. Hi, everyone. I'm Adam. I'm from A-Look Analytics, a small data science company. I'm a data scientist there, and we work with Kebula on various data science projects, but that's the topic of today's talk.
Great. So some housekeeping for today's webinar. All our attendees will be muted, but you are free to send us messages and with your questions, and we will of course come back to you and answer to you offline. The recording will go out after the webinar has been completed, and we will send you everything out. Just a couple of seconds, because it seems like we have delay, but it should definitely everything work. Okay, good. I have the good feedback. So let's get into the webinar. So just a quick introduction to what Kebula is and why Kebula thought about bringing A-Look Analytics and talk about the transactional data. Kebula is a SaaS data transformation platform that helps people just to extract messy data from different platforms. You can think data from your APIs, from different database or text, and prepare it for analysis in a clear state. It's a robust platform, repeatable. It's SQL-based ETL, plus you have also the storage there, and data science notebooks, R, Python, OpenRefine. It's everything under one login with no scaling issue. The exciting bit, I guess, it's that everyone can do it. Since it's SQL based, you have just to have basic knowledge in order for you to use Kebula, and it cuts down the time to clean data from months to days, and it's a full data engineering platform. It's everything under one login, and what this gives you the opportunities to actually work between your colleagues, but also with external people from the company. You can give access to them to specific data, work on it, and if all the data will be sitting inside Kebula under very secure environment, and it's gonna take care of all the data flow from the data sources till the data consumption. So no knowledge inside Kebula is lost. It's a full REST based, it's programmable, extendable via Docker components. So if you have some advanced knowledge, you can use Docker to extend the use of Kebula. It's usable via a console, and as I'm going to introduce you A-Look Analytics is because inside Kebula there is an we call App Store. So it's a market where our customers can get there, so they don't have to exit the environment Kebula in order for them to run some data science applications that they need to run on top of their data. So that's where A-Look Analytics come into the place. A great data science boutique, and we work on different clients actually. The amount of clients that we can help varies from gaming industry, hospitality, e-commerce, retail, and banking. And what's our focus today is to get into the transactional data, what you as a company can do with that data. And first of all, what is transactional data? So let's start from the beginning. And Adam, you have now the presentation.
Okay, so let me turn the screen share on. I hope it will work. So Elena. Can you see my screen?
Yes, we can see it.
Let's get started. Introduction to transactional data analysis. I want to tell you something about transactional data. It's a webinar, so it's a very difficult format of any talk because I have absolutely no idea if I'm talking too high level or too into details. So let's hope I'll find the right balance there. I want to tell you something about how the transactional data look like, and also what are the advantages and disadvantages, and how to make sure that you can help your business grow using transactional data. And I'll tell you something about a few use cases that we did with transactional data. To get started, as Elena said, I'm from A-Look Analytics, which is a small data science company. We don't have any product. We simply built a tailor-made solution for our clients. We operate across industry, from banking to manufacturing to HR tech companies, basically whatever. We always try to help our clients deliver something to their bottom line, because otherwise nobody would be willing to pay us any money for whatever we would do. And obviously we are a proud data science partner of Kebula. My name is Adam. Once again, I'm data scientist at A-Look, and for last 3 years we did something like 60 projects together, and I'll be speaking about some of them because they involved using transactional data during the solution. So let's get started. Before I get to transactional data, let me start with something that I'm repeating every time, and I want to repeat it once again. So if you want to make sure that the analytics have impact to the bottom line, which is like profit of the company, you always need to start with the business issue at hand, and then from the business issue you define the analytical problem, and then only you define what kind of data you need and how you need to transform the data into the features that it help to solve the analytical problem, so that it help to solve the business issue, not the other way around, which is unfortunately still quite often a case, that the client comes and tells us that they have some cool data set and they are curious what we can do with that. So obviously the answer is everything, but usually it won't help anyone or it won't bring any value to the business. So it's not a good idea. Always start with the business issue, and I will show this on a use case examples, and I hope it will be clear, and so on and so on. So transactional data. By transactional data, I simply mean a triplet of who did what and when. Sometimes there can be also added information like time or amount or this kind of stuff, but I'll get to this in a second. From the terminology perspective, this is always called from the Netflix kind of stuff. It's always use terminology that calls the person who did the transaction a user. The product that he bought, or an item, or a movie that he saw is called an item, and then you have something like time. What is quite nice about those data is that it's very simple, and every business has those data in place and in order. So otherwise you won't be able to bill your customers. Otherwise you won't be able to know who should you send what kind of product. So even when our customers are telling us that their data are not in a good shape, or they don't have enough data, or to start with something, they always have transactional data. And it's a good way to start doing any analytics, because you have those data at hand, and you have quite a big flexibility with what actually you can do with the transactional data. The other thing is that those data are typically, you can imagine like a banking statement or a receipt from grocery stores. But technically speaking, those data are available in various kind of industries. You can find them in travel, hospitality, retail, or any kind of sales in general. So this is the biggest advantage about transactional data. So it's not only about banking industry, but it's also about any other industries that are selling something to someone. What is the biggest advantage of transactional data is, given that technically in the simplistic in the simplest way, you are talking about a triplet of data. So 3 information in one data, and when you have multiple lenses that you can apply onto the transactional data, and you can see different things just by using different points of view. So you can run different aggregations. So how much I spend for something, for some products of some category. I can have a look at the frequency. So how often do I go to a garage, for instance? I can look at amounts, so how much money I spent in for different products. I can see time series, how this evolves, and I can see sometimes even location that I know where I'm doing any transactions on the map. This is important. I will speak about the business or potential business usage of transactional data. That you have this unlimited number of views that you can use for because you always need to start with the problem at hand and then define what is the right way to look at your transactional data so that it will help you to solve the problem. Most important thing about transactional data, in my opinion, is that they are backed by the wallet. Which means that the customers actually paid for what you are analyzing. So it's not something like a Facebook-like or something like this. That there is unlimited number of Facebook likes that I can give to some products. But this is really what I spent my my salary for. So it is usually quite a robust data and reliable data source. Okay, so let's get to the main point of the talk, which is what can be transactional data used for. So, as I said, we work on quite a lot of projects. So I just picked some projects from the last 12 months that included more or less transactional data. So there is various things that you can use transactional data for, and which range from churn prediction or any kind of propensity model. You can also do event detection if you are looking on the time series of the transactional data. The very popular and like a flagship of transactional data analysis, in my opinion, is the recommendation engine. But you can do a lot of other stuff. It's always driven by the business problem at hand that the client had. So for churn prediction, the problem was obviously retention. If you want to increase the average number of items per basket, is about recommendation engine. Sometimes the client had problems with the costs or cash flow issues, and then you can run some kind of demand prediction model. But it's always about the business problem. Then you define the analytical problem, and those the list on this slide is basically the analytical problems that can be solved using transactional data. Today I'll speak about two of them because we don't have unlimited time, luckily. So I'll tell you something about churn prediction model and recommendation engine and how those can be solved using transactional data, and what kind of role the transactional data play. Consider this a tasting menu. So it's not something that is set in stone. So, you know, this should be like an example of what can be done. Think about your own business issues. What can be solved using transactional data. Maybe you will find some inspiration in today's case studies. I hope. Good. So churn prediction. Churn prediction is something that you want to find clients that are likely to leave before they do so. So actually, the case here was that we had a client that was a leading e-commerce company on the market. They acquired almost all of their competition over the 3 years of their existence. They generated quite a lot of people in their client. Obviously, after this time, the competition started to crawl back, and they started to steal their customers. So the client had to change from the acquisition kind of strategy to more protective position towards their existing clients, and they had to be careful about not to lose any more customers, because it turned out to be obviously quite expensive to win them back. So So technically, what the strategy here to solve this business problem was to identify customers that are about to leave before they do so, with a time advantage that you can actually have some time to react, so that you can send a marketing campaign to them, something like a retention campaign. The customer already had some kind of a retention campaign in place, but so they found out that actually you can win over the customers that are about to leave, but it was quite cost ineffective, because they had to contact many customers, even those customers that were not likely to leave. So it was more like a carpet bombing, and obviously, you know, the churn or retention campaigns are the most expensive campaigns you can imagine, because you need to offer something really really beneficial for the customer, not for the customer not to leave. So basically, technically, what we are speaking about is the propensity to leave. We need to calculate something that is called binary classification model. We need to train this model on target data, which are, if we look in the future and we see whether the customer left or not, and using those target data, we want to identify similar customers that are also likely to leave, in a nutshell. So always whenever we stand in front of a model that is about to be built, using any data that are available, you always need to think about what kind of features have even a slight chance to predict what you're about to predict. So if you are talking about identifying customers that did a lot of business with you in the past, now they do nothing, how to distinguish those from the customers that are still doing business with you in the meantime. So even like thinking about this problem without any data experience, someone would consider frequency, that if the customer is shopping with you every month, and then he's not doing any business with you for a longer period, he's probably considering some other competition. So what you need to consider is something like a frequency decrease. How to do this is obviously quite simple. You can look at the individual number of transactions that the customer did in the past month, or past week, or 6 months ago, or a year ago, or you can go crazy and compare any of those numbers. So you can create a ratio of number of transactions per month in the last 30 days compared to the same parameter over the last 90 days, and you can generate thousands of those features of the same strategy. So the advantage of the modeling approach, obviously, compared to the expertly set campaign, is that you can generate hundreds or thousands of those features, and the computer will then just simply tells you which of those are important, and train the model that works or that utilizes the information in the best features included in your data set. So you can really go crazy and try different stuff, but always, keep in mind that you need to start with the hypothesis that what kind of, if the feature you are generating has at least a slight chance to predict what you are about to predict. The second thing that you might consider, apart from the frequency, is also amount. So you can see that usually churning customers are spending less and less with you. So you would like to see that the amount is decreasing. So once again, you can calculate any kind of transactional or aggregate the historical transactions, so that you see the decreasing amount in the transactions that the user is doing. The tricky part is that sometimes the company is providing a lot of or selling a lot of products, and those products are different. So you can imagine that if you stop shopping with grocery stores and they have quite nice selection of meat, probably you would do the shopping elsewhere, and until you find a good provider of meat, you will still buy meat from the original grocery store. So this is also what one should look for, and that's that you would like to see the mix of products or categories of products that the user is buying, and that might also change over time, that you would get a different mix of what exactly the customer is buying from you. So you typically can expect that the customer will be buying a lot of product categories in the past, and then he only sticks to those that are not available elsewhere. And the ones that are easy to transfer to some other providers, he will do this immediately, and that can give you a nice information about the potential risk of losing this customer. So you can, what I'm trying to say in quite complicated way, I'm afraid, is that you can do this frequency and amount features, and you can split them by categories or by basket mix, or you can actually just calculate number of categories that the customer is buying, and see how this works. So technically speaking, how all of this is done is that you start with the simple triplet user item, aggregate it in a table that is called modeling table, that basically has all the relevant users in rows, and then any features that you might think of in the columns. So the transactional data play a fundamental role here, and you need to think about what exactly are the features that I should generate from this. So it might be something, as I said, about frequency, amount, and I'm able to generate hundreds of features. And then the standard modeling follows. It's not that complex. You basically start by splitting the sample into train and test. Then you do probably some kind of feature selection if you have too many features generated in the first step. Then you train several models using cross-validation. You pick the model that is performing the best, and you hope that it will work on the test data as well. And if so, you have the model. If the performance is not good enough, usually you can spend a lot of time with the modeling techniques, and you can try to incorporate more sophisticated modeling methods. So usually you start with a logistic regression as a benchmark model, and then you have something more fancier like GBM or random forest or something like this, and you can go crazy and try the deep learning AI kind of models if you have time and will to do this. But at the end of the day, it's also somehow about the transactional data itself and the features generated from them. So it's not only about like throwing transactional data in the raw format into the model. That won't work in most of the cases. So you need to think about the features, and you need to think about what is the business problem you are solving and what kind of features might help. So this is the exercise that you need to rerun iteratively during any modeling approach. So for churn model, as I said, it's always about frequency, amount, basket mix, categories, and so on. And then you should get to a model that is working quite nicely. The other thing is that you should also look for some kind of events that the customer did and that are triggering the dissatisfaction with the services and abruptly increasing the likelihood that the customer will leave. And these are typically linked to the satisfaction. So you can have some kind of lagging and leading indicators about the future dissatisfaction, which is typically, complaints about the delivery service, complaints that the basket was not complete. You might have an information that the customer actually canceled some kind of email notifications and this kind of stuff. And it is also useful to add this to the model, because it can further improve the model performance. Once you have the model, one final note on this is that usually you shouldn't be satisfied with the model output being ones and zeros that are default outputs from many modeling tools. But the modeling tools usually provide you also with a score between 1 and 0 that tells you how likely the customer is about to leave. And then I think the healthy best practice is to run some kind of optimization that you would like to maximize the return on investment of the campaign. So sometimes, people forget that campaigns cost something. So the cost of contact are not 0, and they are usually linear, which is unfortunately not the case for churn prediction model, where you need to provide a better offer to the customers that are more likely to leave, as opposed to the customers that are not that likely to leave, and those that are not at all likely to leave, you don't want to provide any offer. I mean, with the retention campaign at least. So one need to think about how or where exactly the optimization defines the threshold from which I should start contacting the customers. And typically you can have like several layers of retention campaigns, and if make different offers for different kind of thresholds, so that you don't waste more money than it's actually needed. In the case of the client I was speaking about, we at the end of the day we reached something like an extra third to ROI of the retention campaign compared to the standard retention campaign that the client was running in past. So that was churn model. The second example is recommendation engine for today, and I see that I'm slightly running out of time, so I'll be quick. And I think that everyone knows something about recommendation engine. So recommendation engine is a flagship of any transactional data analysis. I think that recommendation engine was at the very beginning of why the transactional data became so popular and why everyone started to mine for information in those data. So basically the business problem usually is increased sales of current customers, so cross-sell, upsell. Sometimes you might have a different business goal at hand, that you might simply want to increase number of products per basket, or you want to maximize the profit or revenue or margin or whatever. But one needs to think about how to actually do this, but I'll get to this in a second. So the strategy here is to recommend extra products that are likely to be bought, which is one part of the overall solution. And this one part can be solved by something that is called recommender system. So recommendation engines are basically algorithms that will tell you how likely the customer is about to buy a product. So what you want to do, you want to maximize this likelihood and offer to each customer a product that are most suitable for them. But this is usually solving just the one part of the equation. The second one is the business goal that you are after, and that might be, for example, maximize the revenue. So what you need to do technically is to calculate the expected value of the overall recommendation that you are giving the customer. So you need to consider how much how much can I violate the recommendations of the user, so that actually I will recommend him something that is not absolutely perfect for him, but I have better revenue from the product, so I can somehow put it higher in the recommendation engine or recommendation output, and the customer is still likely to buy it, and then obviously the expected value for me is higher. So if I have a product that the customer is likely to buy with 20% chance, and I have revenue of 100 euros, then the expected value is 20. If I have a product that where the likelihood of the client buying the product is 50%, and actually the value of the product is the revenue I have from the second product is 50 euro, the expected value is way higher for the second one, even though the recommendation engine in the pure format would recommend the first product above the second one. Anyway, so how you utilize transactions in the recommendation engine is quite simple. So there is hundreds of methods that you can use. All of them are dealing mostly with the first part of the problem, which is recommend the products that the customer will likely buy. So what you do here is always you need to transform the transactional data into something that is called similarity matrix, which basically tells you what is the link between individual users and individual items. So you would like to see that user XYZ bought these products or bought that number of these products, and so on. Of course, you can aggregate the transactions with respect to number of sales the customer did, or how much money he spent for individual products, or you can simply binarize the whole problem, and you just simply say ones and zeros if the ones for the products that the customer has bought in the past, and zeros for those that he hasn't bought. Two comments to this one. First one is that obviously you need to consider some kind of a time dimension in this, because you don't want transactions from 10 years ago to influence the model if they are obviously not that relevant for the shopping behaviors or shopping patterns as the recent transactions. So usually you apply either some kind of window that you only consider the transactions from the last 12 or 24 months or something like this, or you can use some kind of exponential forgetting or any other forgetting, statistical forgetting applied to the data. That's one comment. The second comment is that the problem with the transactional data is that if I haven't bought a product and therefore I will have 0 in the similarity matrix, I don't know if I haven't bought the product because I don't like it, or I haven't bought the product because I haven't known about it. So it's not like with the movies where you have an A for the movies you haven't seen and you have the worst possible rating for the movies that you have seen, but you didn't like them. So that's a similar story there, but one needs to be just aware of this. What is the most important part, in my opinion, is not the recommendation engine itself. So you build a recommendation engine quite easily using any I don't know, Python libraries or whatever libraries you might want, because the algorithms are there and then they are quite simple. You don't have to waste your time with implementing them in using your own code. But you can use what's actually out of the shelf. The second thing is that, or the most important part is that on top of those recommendation engines, why plural, I'll explain in a second. But on top of those recommendation engines, you should build some kind of a machine learning model that will optimize for the business target that you have at hand. So when I was speaking about the maximizing the revenue from the basket, that's actually what happens in the machine learning model. So you want to train a model that will optimize the expected revenue from the basket using the inputs from the individual recommendation systems and recommendation engines, and together with the product revenues will train on the level of individual users how to combine all of this information together so that the expected value is maximized. Usually the recommendation system contains of multiple recommendation engines, so you can train a model that takes into account historical transactions. That's basically what one would imagine as a default option, or the simplest one. The other options might be that you would train another model just using the product views or page views or any other online behavior the customer is doing, or you can simply use popular choices, which are usually quite nice for customers about whom you don't have that much information. And once you do all this, and if you do this correctly, from our experience is that the increase in sales for the recommendation engine is somewhere between 5 and 20%. Obviously, this depends on the context where you build the engine. If the company had nothing in place when we started, or they had some kind of simple recommendation engine in place, depending on this, the increase was different. But that's in a nutshell about recommendation engines and how you can use transactional data within them. So that's it. I hope it was something that was find interesting, and I'm sending the share screen back to Elena, if I will be able to do so.
Yeah, no worries.
Okay,
about transactional data from Adam, it's by joining our event that we are hosting next Tuesday on the 27th of February. This information we will send you across via email with the replay to this webinar, and you can find all the details both on Facebook and on Eventbrite. We will redirect you to those links where you can register. It's a free event. Everyone is welcome. Those who are interested in learning more about transactional data are more than welcome to join us. So thank you very much for joining us today, and we look forward to see you in the next webinars that we will create with you. So thank you, Adam. Thank you a lot for sharing your knowledge.
Thanks a lot.
See you. Thanks. Thank you. Bye-bye.
Take care. Cheers. Bye-bye.